Welcome to AP Pre-Cal and the first lesson. So the first lesson is called Change in Tandem, and you all can read this on your notes, but these are the standards, and I'm just going to go on because you can read that. All right, a function is a mathematical relation that maps a set of inputs to a set of output values such that one input value or each input value is mapped to exactly one output value. So one value of X will only have one value of Y. Y can have multiple values of X, but X can only have one value of Y. Yes. So the X cannot repeat, but the Y can. Okay, that's about the best way to put that. So remember what I said about on the AP exam, if you're ending up with a free response question and you're answering that free response question, you cannot put down as your reason for a function being, for a relation being a function as it passes the vertical line test. That is no longer acceptable. And you'll understand why when we get further along in AP Pre-Cal. It'll become apparent why we can't do that. But you need to say that each input has exactly one output. That's what you need to say. We will also be doing polar functions later on. And it says that polar functions fail the vertical line test. Not all the time, but often. But they are actually functions. So that's the reason why we don't say that. The set of input values of a function is called the domain, and it is represented by the X variable or the independent variable. The set of output values is called the range, and it is represented by the Y variable or the dependent variable. Okay, a function is positive when the graph of F lies above the x-axis and the outputs are greater than 0. Now, I'm going to do a third video over sections 1.1 and 1.2 later on today and clear up some of these things that I don't feel like these notes go into enough depth with. A function is negative when the graph lies below the x-axis, and that's when the output values, the Y values, are less than 0. Now, in Pre-Cal, we're going to be looking at multiple representations of functions. We're going to look at it in graph form, look at it in equation form, table form, and verbal form. And we're going to be going back and forth between all those. Now, graphical behavior functions. A graph is increasing when the graph is going up. That makes sense. So as the X values go this way, go up, if the Y values also go up, it is increasing. If when the X values are increasing, the Y values are decreasing, we call that a decreasing function. And I have little circles put on the end because it's like, as you look at the graph, as you push a rock, which way are you pushing it? I'm behind it and pushing it. This is going up. I'm behind it and pushing it. This is going down. Here, concave, this is concave up, looks like a smile. Concave up, and concave down looks like a frown. And so, or you could think of this as a cup as well. And the rate of change is increasing in these when it is concave up. And this one, the rate of change is decreasing when it is concave down. And like I said, I don't feel like these notes went into enough depth, so I will be creating more about that and more practice for you to practice those concepts. When we write intervals of increase or intervals of decrease, we always write those using X. So just keep that in mind. All right, now we have this graph here. And we are looking at this graph. See that graph there? I'm going to pull it up just a little bit more so we can see the questions. The graph of h of x is shown below. Use the graph of h to find the open intervals where x has the following behaviors. Where is the graph of h increasing? Well, it is increasing from here. That's the first place that it increases, and it goes up to there. So that's our first interval of increase from -2 to 0. Remember, we use x values. And then it is also increasing. I start pushing my rock up again from here to there. So it is also increasing from 4 to 7. And I write a union. I've seen some other teachers just write the word and I don't care which way you do it. This one is decreasing from -4. So the graph is going down from -4 to 2. It is also going down from 0 and has a point of inflection right here, but it's still going down all the way to 4. So from -4, I wrote, yes, -4 to -2. And I thought there for a minute I'd written it wrong, but I did not. And from 0 to 4, it is decreasing. Where is h concave up? That's, where is it like a cup? From 2 all the way to 7. Where is it increasing and also concave? Down. All right, so increasing here from -2 to 3, but it is concave down. It is pointing down. So from -2 to 3, it is an increasing, -2, I'm sorry, to 0. That's 0. So from -2 to 0, it is increasing and concave down. And this one is decreasing and concave up. So it's decreasing here. Let's do this in this color so you can see it. Decreasing here, but also concave up. Now, this one, I remember when we did this in class that we were all, including me, struggling to do this. So what I did is I wrote down everything that it says. I wrote it off over here to the side so that I could see it all together instead of in words. So it is increasing from -4 to 1 and 5 to 7. And what I did is I just drew a straight line going up. And you could have put this anywhere. You could have put it up here. You could have put it down here. It doesn't matter. But so I did the increasing from -4 all the way to 1. I just drew a straight line. And then it is also increasing from 5 to 7. So I drew a straight line right here in red. So my increasing is in red. And then I did my decreasing from 1 to 5. And then I looked at the concave up and the concave down. It is concave up from 3 to 6. So I took my little marker from 3 to 6 and drew myself a little cup to 6, like that. And then it is concave down from -4 to 3. So we want to draw a frown from -4 to 3. So I drew myself a little frown and connected it there. And then it is also concave down from 6 to 7. So I took from 6 to 7 and did this little hook. So the graph that we're looking at is not what I drew in red and black. Now I didn't try to erase it up here on this board because it would erase my blue. But if you had your pencil, what you would do then when you drew this in pencil is you would just erase your straight lines and you would have the shape of the graph. So my graph is going here and then here and then curves up like that. So that is what is going on there. Okay, thank you.